So last week we looked at one algebraic way of solving systems of equations, and that was by using substitution. We took one equation, got one variable by itself, sub that into the other equation. That gave us a new equation with only one variable that we could solve for. And then we took that answer and plugged it into one of the original equations to find the other variable. So that is one way that we can solve systems of equations algebraically. Another way is by using something called elimination. You can solve a linear system of equations using this elimination method. It is an algebraic method of solving a system of equations. To solve an equations by this method, a variable in both equations must have the same or opposite coefficient. Sometimes you need to multiply one or both equations by a constant to get that you have the same or opposite coefficient in front of one of the variables. And then we either add or subtract the entire equations to eliminate one variable and solve for the other. So some hints: simplify equations first. Also line up like variables so that the two equations are in the same order. The terms are all in the same order. One suggestion is to put all the x's on one side equal the constant on the other. You don't necessarily have to do that. That's just one suggestion. But you do have to line up all of the x's, all of the y's, and the constants. So, example 1, solve each by elimination, verify each solution. If we look at these two equations, the coefficients in front of the y's are opposites. Okay, Liam? The number in front of the y in the first equation is a positive 2. The coefficient of the y in the second equation is a negative 2. 2 and negative 2 are opposites. The first step is already done for us in this case. The coefficients in front of the y's are opposites. So now what we would do is we would add these two equations together. Because the coefficients in front of the y's are opposites, when you add the y's together, you're going to get 0. Because positive 2 plus negative 2y is 0. They cancel each other out. But we also have to add the x's. 3x and 5x is 8x. Once again, when you add negative 2y and positive 2y together, you'll get 0. Y's are just 0. They cancel. And then when you add 19 and 5 together, you'll get 24. You add the x's together, the y's together, and the constants together. And the reason we're adding is because the coefficients in front of the y terms are opposites. So when you add them, they cancel. So we'll just have 8x equals 24. And then when you divide both sides by 8, x will equal 3, because that's what you get when you divide 24 by 8. So we're halfway there. We're looking for the solution to the system of equations. Remember, that is the point of intersection if you graph the two lines. That's what we did in chapter 8. Right? We graphed the lines to find the point of intersection. We're halfway there. We have the x value at the point of intersection. To find the y value, take that x and plug it into one of the original equations. For no reason, I'm going to use the first one. I'll let x equal 3 in that equation and then find out what y must equal. 3 times 3 is 9. So you're going to get 9 plus 2y equals 19. When you subtract the 9 from both sides, you'll get 2y equals 10. And then when you divide by 2, y will equal 5. So we are saying then that our point of intersection is the point 3, 5. We found x to be 3, plugged that in, and found y to be 5. So what we need to do then is to check. And if you're asked to verify your solutions, you must show this step. Show that you are checking. So when x is 3 and y is 5, 3 times 3 is 9, 2 times 5 is 10, 9 and 10 gives us our 19. So it checks for that one. But we also need to make sure it checks for the second equation as well. Remember, the point of intersection is a point that lies on both lines, and it's a point that satisfies both equations. So you need to check it for both equations. 5 times 3 is 15, take away 2 times 5 is 10, 15 take away 10 is also 5. So it checks. We have just shown that this is the correct answer. It is the point that satisfies both equations, so it would be the point of intersection. All right, looking at question B. Notice that the x's have the same coefficient in front of x. So in this case here, if we want to eliminate the x's, we would subtract the two equations. Because 4x take away 4x cancels. 4x minus 4x is 0x or just 0. Now you have to remember you're subtracting here. So when you do the y's, it's 3y minus negative 7y. The minus minus becomes a plus positive. That's going to become 3y plus 7y, which is positive 10y, equals, and when you subtract 5, take away 15, you're going to get negative 10. So you'll have 10y equals negative 10, and now we would divide both sides by 10 to get y by itself. Negative 10 divided by 10 is negative 1. We're halfway there. We found the y value at the point of intersection. To get the x value, take that y value, plug it into one of the equations. It doesn't matter which one. I'm going to use the first one. So I'm going to let y equal negative 1. So we'll get 4x minus 3 equals 5. If we add 3 to both sides, 5 plus 3 is 8. And then divide by 4. 8 divided by 4 is 2. So we are saying that our point of intersection is the point 2, negative 1. We found that x equals 2 when y equals negative 1. And so we're going to check. We're going to verify. If it is the point of intersection, that means it has to be a point that lies on both lines. That point needs to satisfy both equations. Okay, 8 take away 3, which is 5, so it checks for the first equation. Now checking the second equation. 4 times 2 is 8. Negative 7 times negative 1 is plus 7. 8 plus 7 equals 15. It checks. It satisfies both equations, so therefore it is the point of intersection. So when we looked at question A, the coefficients in front of y's were opposite, so we added them together. With question B, the coefficients in front of x were identical, so we subtracted the two equations. If we look at question C, the coefficients in front of x's are not the same or opposites, neither are they for the y's either. Okay, so in this case, we're going to have to do one extra step, an initial step, before we can add or subtract. And what I'm going to do here is I'm going to multiply the entire equation by 2. Because that'll give me a 2x, which will line up with the 2x from the other equation, and then I can subtract. But I have to multiply all the terms by 2. The x at the start gets multiplied by 2. 2y times 2 is positive 4y equals negative 3 times 2 is negative 6. So I multiplied the entire equation by 2. That gave me the same coefficient in front of the x's. So now I will subtract the equations. 2x take away 2x is 0x or 0. They cancel. Not even going to write 0 down there. 4y take away 3y is 1y or y. And when we subtract the constants, it's negative 6 minus negative 4. The minus minus becomes a plus positive, so it's negative 6 plus 4, which is -2. And in this case, we're halfway there, right? It's 1y equals -2. So y is -2. To find out what x is, we'll take that number and plug it in for y in one of the equations. I'm just going to use the first one. The second one would work as well. And notice I'm using the original equation. X plus 2y equals -3. 2 times -2 is -4. And then when you add 4 to both sides, x will equal 1. We are saying that our point of intersection is the point 1, -2. So that's what we were going to use in our checks to verify. So it's 1, and then 2 times -2 is -4, and 1 minus 4 is -3. So it checks for the first equation. Two times x is 1, plus 3 times y, which is -2. You're going to get 2 take away 6, which is -4, so it checks for that as well. We've just shown that our solution works. It satisfies both equations, so it would be the point of intersection if we graph them. All right, so a couple things about example D. The coefficients in front of x are not the same or opposites. The coefficients in front of y's are not the same or opposite either. And in this case, we're going to have to multiply both equations by a constant. The other thing we'll make sure we do is change the terms around in one of the equations so that they line up. Because right now, the x's line up, but the y's don't, and the constant terms don't either. Right? The 17 is lined up with the 25y. We need them to be like terms. It doesn't really matter if you say you're going to eliminate the x's or the y's. It's probably going to be easier to eliminate the x's, only because it'll mean multiplying by smaller numbers. I can do that if I multiply the first equation by 3, because 10x times 3 is 30x, and then the second equation by 2, because 15x times 2 will also give us 30x. Sometimes you have to multiply both equations by a constant. So again, multiplying the entire first equation by 3. 10x times 3 is 30x. Now, in this case, I'm going to put the y term next. -15y times 3 is -45y, and 17 times 3 is +51. The entire second equation is multiplied by 2, which will give me 30x equals 25y times 2 is 50y. -3 times 2 is -6. And because the two equations have positive 30s in front of the x's, we need to subtract the equations. If the coefficients are opposites, you add the equations, but in this case, they are the same. So 30x, take away 30x is 0. On the right side, -45, take away 50 is -95y. And 51 minus -6, the minus minus becomes a plus positive. It'll be 51 plus 6, which is +57. So to solve for y, I would add the 95y to both sides. And then we would divide both sides by 95 to get y by itself. So let's use the calculator to help us do this part. 57 divided by 95. That wasn't so bad. It's 0.6. That's what y is. So to find x, we'll take that y value, plug it into one of the original equations. I'm going to use the first one, although it wouldn't matter. I could use the second one as well. So I'm going to let y equal 0.6 and then solve for x. So 15 times 0.6 is 9. 17 take away 9 is 8. And then divide both sides by 10. And x will equal 0.8. 8 divided by 10. Because y is a decimal, I'm writing x in a decimal as well. So our solution is 0.8 comma 0.6, which we need to check. Make sure it works for both equations. When you multiply 10 by 0.8, you're going to get 8. So 15 times 0.6 is 9, and 17 take away 9 is 8. So it does work for the first equation. Now we need to make sure it works for the second equation as well. So on the left, 15 times 0.8 is 12. On the right, 25 times 0.6 is 15. And 15 take away 3 is also 12, so it checks. We have just shown that our solution works. Now for number 2, one of the hints at the start said to simplify equations first. So we're going to do that in this case. We are going to write this equation without any denominators by multiplying all the terms by the common denominator. For the first equation, that would be 12. The least common multiple of 3 and 4. So we're going to start by multiplying every term by 12. Because 12 divided by 3 is 4m, plus 12 divided by 4 is 3n, and that equals 24. So there's the first equation simplified. And we need to do the same thing with the second equation by multiplying all the terms by the common denominator of 6. So it's going to be 6 times 2m over 3 minus 6 times n over 2 equals 0 times 6. 6 divided by 3 is 2, times 2m is 4m, minus 6 divided by 2 is 3n, and that will equal 0. So if we line up these two equations, you should realize that in this case, we can either add or subtract. After we got rid of the denominators by multiplying all the terms by the common denominator, the coefficients in front of the m's were exactly the same, so we could subtract the equations and eliminate m's. But the coefficients in front of the n's are opposites, so we could add and eliminate the n's, one or the other. It's usually easier to add than it is to subtract, so that's what I'm going to do. 4m plus 4m gives us 8m. 3n plus negative 3n, they cancel. 24 plus 0 is 24. So then we'll divide both sides by 8, and m equals 3. I'm going to use one of my simplified equations to find out what n is. I'm going to use this 4m take away 3n equals 0. 4 times 3 is 12. So when we add the 3n to both sides, we'll get 12 equals 3n, and n equals 4 if we divide both sides by 3. Okay? So if we write our solution in alphabetical order, which is m, comma, n, it would be the point 3, comma 4. And to check it, we need to use the original equation. So m is 3, so it'll be 3 over 3 plus n is 4. 1 plus 1 equals 2, so it checks. For the first equation, we need to check for the second equation as well, though. So 2 times m is 3. 2 times 3 is 6 over 3, minus n is 4 over 2, gives us 2 minus 2, which is 0, so that one checks as well. We've just shown that our solution works. And for the last one here, we need to multiply out the brackets first. So multiply out, the brackets first. Gives me 2a minus 8 plus 5b plus 5 equals 8, or 2a plus 5b, negative 8 plus 5 is minus 3, or 2a plus 5b equals 11 when you add the 3 to both sides. So there's our first equation, simplified. You need to do the same thing for the second equation as well. First step, multiply out the brackets. Negative 3 and 4 is positive 1. And when you subtract the 1 from both sides, because you want it in the same format as the first equation, you'll get 3a take away 2b equals negative 12. So if we look at these two equations, the coefficients of the a's are not the same or opposites. Neither are the coefficients in front of b's. This is one of these ones we're going to have to multiply both equations by a constant. And it doesn't matter. You can eliminate the a's or the b's. It doesn't matter. For no reason, I'm just going to decide to eliminate the b's. Because if I multiply the first equation by 3, I'll get a 15b. Sorry, not 3, 2, to get 10b. And then I'll multiply the other equation by 5 to get a negative 10b. That's what I'm going to do here. So the first equation times 2 gives us 4a plus 10b equals 22. The second equation times 5 gives us 15a minus 10b equals negative 60. Because the coefficients in front of the b's are opposites, we will add these equations together. 4a plus 15a gives 19a's. When you add the b's, they cancel. So finally, I'm going to add 22 and negative 60. That gives me negative 38. And when we divide both sides by 19, a equals negative 2. To find out what b is, I'm going to take that value of a and I'm going to plug it into one of the simplified equations that I came up with. I'm going to use the first one, 2a plus 5b equals 11. So negative 4 plus 5b equals 11. If you add 4 to both sides, 5b will equal 15. And then divide by 5, b will equal 3. So if we write our point in alphabetical order, it'll be negative 2 comma 3. That's what we need to use in our check. And again, when you check, you should always use the original equation. So a is negative 2. B is positive 3. Negative 2 take away 4 is negative 6. 3 plus 1 is 4. Then we get negative 12 plus 20, which does equal 8. So it checks for equation 1. And now we need to check for equation 2 as well. So again, a is negative 2. C is 3. So you're going to have 3 times negative 3 minus 2 times 1. Negative 9 take away 2 is negative 11. So it checks. We've just shown that our solution works. We're going to do questions 1 and 4 on page 488, 489, and this one you're going to hand in. Nope. The one on the next page is tomorrow's lesson. So this is out of the textbook, which I think if you scroll ahead, these questions should be in your package.
1 and 4 or
1 and 4.
So, yeah.
That's what the comma means.
Yeah. Yeah, it's gonna be.
Is that page 488, 489?
Yeah. No, it is that.
Says it at the bottom.
Yeah, here.
Do you know the 88? 488.
No, this one.
Just
The 4 is missing.
Also, I wrote on the board here, Friday, June 9th.
Last day is 7.
Last day to hand in any of your missing assignments is Friday, June 9th.
this week?
Is this
Oh,
June?
My fault.
You've got about a month. Yes.
Yeah.
I can't find like my missing ones.
What do you mean you can't find your missing
Like
ones?
it's not in my bag. I need a new one.
So then if you need stuff, you need to make a list of what you need.
Okay.
If it's not a textbook, because textbooks, you can use your textbook for it. But if it's homework sheets that were in your package, you need to give me a list.